Hey class, today's lesson is binomial distributions, which is found in section 11-8 of your book. Our objective is to find binomial probabilities and to use binomial distributions. So let's talk about binomial experiment. A binomial experiment has these important features. They are fixed, there are a fixed number of trials. So for example, you know that there will be 7 trials or exactly 8 trials, okay? And in each possibility, you have 2 possible outcomes. The fact that it has 2 possible outcomes makes it that binomial, okay? So either yes, it's going to happen or no, it's not going to happen. The next one is the trials are independent. So in other words, each trial has nothing to do with the other one. So for example, just because I scratch off a card here doesn't mean that it has anything to do, it doesn't better my chances of scratching on another card. So it means that they are independent. And then the last one says the probability of each outcome is constant throughout the trials. So again, the probability of it out of the 2 possible outcomes is either yes or no. It's always yes or no throughout the whole thing. All right, then we're going to talk about binomial probability. It says, suppose you have n repeated independent trials. So n is the number of trials, just like it's been the number of terms, the number of whatever, okay? Each with a probability of success p. So p stands for success. It says, and a probability of failure Q. So P is success, Q is failure. And obviously, success plus failure has to equal 1. It has to equal 100%. It says, then the binomial probability of X successes, so the number of successes in the N number of trials can be found using the formula P of X equals combination of N choosing X, P to the X power, Q to the N minus X power. And I know that sounds really confusing, and we will somewhat use the formula, but I have another way of also showing you exactly what we mean. So let's go ahead and look at our first example. It says, as part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of awarding a prize. Suppose you have 5 cards. Find the probability that exactly 4 of the 5 cards will reveal a prize. All right, so we need to go ahead and write our formula. Our formula is P of X equals N choosing X, P to the X, Q to the N minus X. And then we need to identify our unknown. So N, the number of cards, is 5. X, the amount of wins that we want, is 4. P, the probability of success, is 40%. But we need that as a decimal. So that is going to be 0.4. And obviously Q, the number of failures, if you have 40% as an award, then 60% or 0.6 is the failure rate. So here's our formula. We're going to have 5 choosing 4. Okay. Probability of 0, it's not P anymore, sorry. P is now 0.4, so 0.4 to the X power is 4. And then Q, 0.6 to the N minus X. So N minus X here is 5 minus 4, which is 1. Notice anytime these numbers here, 4 and 1, they have to add up to 5. So if you know exactly what this is, just subtract it, or know that it has to add up to whatever that first value is in. Okay, now to find 5 choosing 4, it's a combination function. We're going to type it in on our calculator. So depending on what type of calculator you have will depend on how you type it in. But the type of calculator that I have, you would press 5, go to the math button, go over to PRB, which stands for probability, go down to number 3, which is NCR, press enter, and then press 4 and enter, and you should get the value 5. So 5 choosing 4 is actually the value 5. And then 0.4 to the 4th power is going to be 0.0256. And then 0.6 to the first power is still 0.6. Now, by the way, normally I would not write these out because a lot of times your decimals are going to repeat. So I would have just typed this whole part into the calculator to multiply together. So anyways, if I multiply that times 5 and times 0.6, my final answer is 0.768, or about a 7.7% chance of the probability that you will draw, or that you will get exactly 4 of the 5 prizes, or that you will reveal exactly 4 of the 5 prizes. Okay, so again, let's go back through this. We needed to write our formula. We needed to find the parts of our formula. N, remember, stands for the number of terms, which is 5. X is what you want, so that's 4. P stands for the probability of success. In this case, it was 40%, so we had to change that to a decimal. And Q was the chance of failure. So if I had 40%, failure must be 60%, so that's 0.6. Plug everything where it goes, multiply it all out, and that's what you get. So let's go ahead and do our try. It says in example 1 is the probability that the number of cards that reveal a prize is 1 or is 2. So in other words, we're changing x to 1 and we're changing x to 2 in both of these situations. So I'm going to split this in half. So this first one would be p of 1, because I want exactly 1. P of 1, so that'd be 5 choosing 1. P, which was 0.4, again, to the first power, and this would be 0.6 to the fourth power. On the other one, we're having P of 2, because we want 2 to win. That'd be 5 choosing 2, 0.4 to the second power, and then 0.6 to the third power. All right, so in my calculator, I'm going to press 5, math, go over to probability, go down to NCR, and 1. That will give me 5. So it's going to be 5 times these two numbers here. So I'm going to type that in: 5 parentheses 0.4 raised to the first power, parentheses 0.6 raised to the fourth power. Again, if you can, try and type it all in at once, but you got to use your parentheses. And in this case, the probability of getting exactly 1 to reveal a prize is about you're going to get 0.2592, which is about, as a percentage, that's about 25.9%. All right, and the next one, again, 5 math, because now we're choosing 2. That would give us 10. So then 10 times those two numbers. So the probability of choosing 2 is about, let's see, that's 10 parentheses 0.4 squared, and then parentheses 0.6 cubed. And that gives us about 0.3456, which is about 34.6%. Alrighty, let's keep going. Alright, so binomial theorem has a lot to do with Pascal's triangle. If you can remember Pascal's triangle, which is what I'm going to try to choose to focus on when we do our next section with expanding binomials, it's a lot easier with Pascal's triangle. However, when they ask for exact terms, it can be a little difficult. So anyway, here we go. We have, if you remember the Pascal's triangle, it will start with 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. It can go on and on, right? So we will use this in place of our C in the upcoming ones. It's the same thing as if we had used it in this case. However, we will, I'm just going to choose to stick with Pascal's triangle. If you would like one-on-one and want to know how to actually use the formula to truly figure it out, we can talk about it. All right, so it says use the binomial theorem or Pascal's triangle to solve. So in the first one, I have x plus y to the 5th power. All right, so what this means, if you remember from when we did Pascal's triangle, that means that it's the 5th level. So if I do my Pascal's triangle in the center, that'd be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So that's the 1, 2, 3, 4. This is the fifth row because remember we don't count the first one, the very top one I mean. And so these will be the coefficients of our numbers. And remember the first term will be the actual power, and then this y will be the lowest power. So the lowest would be 0. So if we wrote this all out, we have 1, 5, 10, 10, 5, and 1. Everything is going to have an xy. It should all be addition, by the way. Because it's positive. And then from here we just need to write our power. So remember, x is going to be fifth and then descending. So fifth power, fourth power, third power, second power, first power, no power. And then on the y's we're going to go backwards. So fifth power, fourth power, third power, second power, first power, no power. And so as a final answer, our answer is going to be x to the fifth plus 5x to the fourth y. Plus 10x squared y squared, that's cubed, sorry. Plus 10x squared y cubed, plus 5xy to the fourth, plus y to the fifth. That would be our final answer for that one. All right, so then to do the next one, I'm going to see if I can do this without erasing anything. For this one, it's asking for the fourth row. So we need to use this information here. So if I just write out that information, that's going to be 1, 4, 6, 4, 1. I'm going to write 2x and negative 3y for all of them. So that'd be 2x, negative 3y, 2x, negative 3y, 2x, negative 3y, 2x, negative 3y, 2x, negative 3y. All right, so again, we're going to start with the fourth power. So for the first term, that'd be fourth, third, second, first, no power. Then fourth, third, second, first, and no power. And then from there, we're going to simplify. So here we're going to have 2x to the fourth. So that's really 2 to the fourth and x to the fourth. Remember, 2 to the fourth is going to give us 16. So this is 16x to the fourth for the first one, because anything raised to the 0 power is 1. So that goes away. The next one we have, I'm just going to say plus for now, 4 times 2x cubed is really 8x cubed, and then negative 3y. We'll come back to simplifying. Plus 6 times 2x squared is really 4x squared, and negative 3y squared is really 9y squared. Plus 4 times 2x times negative 27y cubed, plus our very last one, which is, let's see, 3 to the fourth should be 81, so it's going to be 81y to the fourth. So we'll finally simplify, and our final answer will be 16x to the fourth minus, let's see, 4 times 8 times 3 is 96x cubed y, plus 9 times 6 times 4 is 216x squared y squared, and then minus 4 times 2 times 27, minus again 216xy cubed, plus 81y to the fourth. And that's our final answer for the second question. All right, let's go ahead and do the try. So we have 3x plus y to the fourth. And again, let's start by creating our Pascal's triangle, knowing that we need the fourth row. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, And I think that is the fourth row. So 1, 2, 3, 4. Yep. We want this one. So we're going to start by putting 1, 4, 6, 4, 1. Start by writing 3x and y for each one. This should all be addition because our sign is addition in the middle. And then we're going to start with our powers. So this is going to be fourth, third, second, first, 0, fourth, third, second, first, and 0 power. So again, 3 to the fourth. Remember, 3x to the fourth is really 3 to the fourth, x to the fourth, so it's going to be 81. That's a bad 8. 81 x to the fourth plus 4 times, that'll be 27x cubed y, plus 6 times, let's see, that'll be 9x squared y squared, plus 4 times 3xy cubed plus y to the fourth. And finally simplify that further to get 81x to the fourth plus 27 times 4 is 108x cubed y plus 54x squared y squared plus 12x y cubed plus y to the fourth. And that'll be it. Alright, so vocabulary. It says a probability distribution is a function that gives the probability of each outcome in a sample space. To find the full probability distribution for a binomial experiment, we use the binomial theorem to expand the binomial below, which is p plus q to the n. Alright, in example 3, we're applying binomial probability. So it says each hour at a cell phone factory, quality control tests the durability of 4 randomly selected phones. If more than one fails, quality control rejects the entire production for that hour. If in 1 hour 95% of the phones made are acceptable, what is the probability that QC rejects that hour's phone production? Okay, so here's what's happening. We have 2 instances here. Well, not really 2 instances, but we first need to know our formula. And our formula is p plus q to the nth power. And specifically, what may be confusing about this problem is the language that is being spoken. Now remember, P is a probability of success, but remember, success is what we want, not necessarily what, is actually considered a success actually, because here we're talking about successes and failures. So what we want, it says, what is the probability that they will reject that hour's phone production? So we want as our probability of success, we want the failure. So the failure would be 5%. So 0.05 would be the probability of failure, because Q is the probability of success. And in this case, 0.95 was the success rate. So let me go back. What the success is what we want. P actually stands for success, but success is what we want, what the question wants. The question wants for it to reject it. So the rejection here is 5%. The Q, which normally stands for our failure, but the failure would actually be a success here. So our failure is 95% because it is considered acceptable at 95%, but really what we want is rejection. So I hope that kind of clears it up. So again, success is what we want. All right, so with that being said, we really have p plus q to the nth power. So it's p plus q to the, and there are 4 phones, so n is equal to 4. So I'm going to write our coefficients down here. So it's 1, 1, 4, 6, 4, and 1. I'm probably going to run out of space. Let me not spread them so much. 1, 4, 6, 4, and 1. Okay, so we have 0.95. Sorry. P is 0.05. Q is 0.95. 0.05. 0.95, 0.05, 0.95, 0.05, 0.95, 0.05, and then 0.95. And again, we use our powers again. So this is it's 4, 3, 2, 1, 0, and this one's 4, 3, 2, 1, 0. That's a 4. Okay, now with that being said, moving past that point, the question says, what is the probability that they will reject that hour's phone production? But remember, they're only going to reject if more than one fails. If more than one fails. So in this first instance is when 4 fail exactly. This one is when 3 fail exactly. So these are still more than one. This one is when 2 fail exactly. The next one is when 1 fails exactly, but it said more than one, so we actually don't want this information, nor do we want that information. Okay, so literally all I'm going to do is just add up all of this information. Only right in here. Okay, so that first one would be 0.05 to the 4th power plus 4 times 0.0. Let's see, 0.05 to the 3rd times 0.95 to the 1st. And then I still need to add that to 6 times 0.05 squared times 0.95 squared. And that will give us about 0.01. I'm just going to do what the book is saying, so 0.1409. But as a percentage, what that means is that it's about a 1.4% chance that they will reject that hour's phone production. So again, the trickiest part about this question is that you want to know what P stands for. P stands for what the question wants. The question wanted the rejects of this problem. The rejects of this problem were 5%. What was considered a failure was if it did good, which was 95%. So in this case, it was kind of like opposite lingo, but everything else pretty much is kind of like what we've been doing with binomial expansions. So let's try the next one. It says a multiple choice quiz has 5 questions. Each question has 4 choices. If you guess every answer, what is the probability of getting at least 3 correct? So in this case, so we still have P plus Q to the nth. But in this case, P is getting a correct guess. So there's nothing confusing here. Q in this case is an incorrect guess. Okay, so with that being said, the probability of getting a correct guess if you have 4 choices on a problem, that's a 25% chance of getting it right, and a 75% chance of guessing incorrectly. And then N, in this case, is the number of questions, which is 5. So to get the 5th row, remember the 5th row was the one that was 1, let's see, it's 1, 5, 10, 10, 5, and 1. Okay, and remember that this one, the first one, starts with, well, all these are, let me go ahead and write this. This is 0.25. I'm skipping out on parentheses because I'm out of space. Actually, I'll just put them on there. 0.25 and 0.75, or I'll put them below it. 0.25, 0.75, 0.25, 0.75, 0.25, 0.75, 0.25, 0.75, and the last one. Okay, remember on this first one, if we're at 5, this is 5th, 4th, 3rd, 2nd, 1st, 0, and then 5th, 4th, 3rd, 2nd, 1st, and 0 power. But it says, what's the probability of getting at least 3? So to get at least 3, that'd be 3, 4, and 5. So I only want, this is 5 correct, this would be 4 correct, and this would be 3 correct. I do not need these 3 at the end. And then I'm just typing it on my calculator. So that'd be 0.25 to the 5th power. And then I'm going to add that to 5 times 0.25 to the 4th times 0.75. And then again, I'm going to add that to 0.25 cubed. Actually, I forgot. I need to add that to 10 times 0.25 cubed. Times 0.75 squared. And that's the last one. And our answer is going to be I got about 0.953125, which is about a 95.3% chance of getting at least 3 correct on that test. I just want to verify that that's right. And actually, I'm going to take that back, and I apologize, but this is actually a calculator error. I had to go back and double check my work. I made a small mistake in my calculation, so really it's about, because I thought that number sounded high, it's about 0.10351, I'm going to say dot for now, which is about a 10.4% chance of getting at least 3 correct. And that makes a lot more sense. Alrighty, so that is it for this lesson. If you guys have any questions, please be sure to come see me for tutoring.